Our final session is entitled LNG as Fuel, Technological Challenges and Innovative Solutions. Our moderator for this panel is Mrs. Helen Polychronopoulou, Executive Vice President of Environmental Protection Engineering SA, EP. Joining her on the panel are Dr. Joseph Florentin, who's the Poseidon Med II Project Manager, the Director of the New Projects Department, Hellenic Gas Transmission System Operator, DESFA, Mr. Dionissis Christodoulopoulos, Managing Director of MAN Diesel and Turbo Hellas, Mr. Joris, Glorie, Business Development Director of Cryonorm Systems BV, Mr. Dionysios Antonopoulos, General Manager of Marine Solutions Sales, Wärtsilä, I think I'm pronouncing it correctly, Professor Christos Douligeris of the University of Piraeus, Mr. Joris van Kreij, Global Business Development, Marine LNG Solutions, Chart Industries Incorporated, and Dr. Paul Davies, Technical Manager, Risk Assessment, LNG and Alternative Fuels at Lloyd's Register. We're a little bit over time. I don't want to take time from this panel, but if you can be as concise and as to the point as you can, it would be much appreciated. Thank you.
Thank you all for staying until the end to watch this final panel. So we have seen already the trends in the LNG as fuel for ships industry. We have seen all the legislative drives. We have seen the market drives. We have discussed about the market drives. We have discussed about financing, and now it's time to discuss about the technological aspects, where we stand in terms of technology, what are the challenges, what are the innovations, what are the steps ahead. With EP, we have been participating in Poseidon Med I, and now we are partners also in Poseidon Med II. And when we started 3 years ago, we realized one thing, that the technology for cryogenics, for liquefied gases, is not something new. It's there, it exists, it has been there for many years. Also, the transportation of liquefied natural gas is not something new. It's something that has been going on for years as well. There are vessels in the sea that are 40 years old and still good as new, doing the same job. The big question is how we combine all these technologies on board ships in order to provide a cost-effective, according to the regulations, solution that will be helpful for the ship, will be easy for the crew, and will be safe for the port and for the infrastructure. So this is what we are going to discuss now. We have a very good panel of experts covering all the aspects of technology. And without any further delay, I will start with Mr. Florentin. Dr. Joseph Florentin, who is the director of the new project departments at the Hellenic Gas Transmission System Operator, DESFA, with 30 years of experience in the natural gas industry, and will present us the infrastructure from the terminal perspective. Mr. Florentin.
Thank you, Chairman. Ladies and gentlemen, I'm Joseph Florentin, project manager for Poseidon Med II on behalf of DESFA, and head of the new projects department in DESFA. What we are going to see in my presentation is how Revithoussa was selected as the center for the supply of LNG bunkering fuel in Greece and in the southeastern Europe region. What are the strong points of our terminal for the small-scale LNG activities, the roles of the terminal, a description, which is very useful for those who have not yet had the opportunity to visit the island, and our current and future works. Revithoussa is at the center of the Poseidon Med II action because it was selected in the previous Poseidon Med program against two other options. One was the installation of large LNG tanks in the port of Piraeus, and the second was the installation of a floating storage unit outside the port. Why was the Revithoussa option retained? It was retained for all these very important reasons, it is at short distance from the port of Piraeus, 17 to 18 miles. It offers easy permitting of the additional infrastructure compared to the case when we want to create grassroots installations. It offers, and this is equally important, open access to all users without creating any constraints for the ship owners regarding their LNG suppliers. And last but not least, we have experienced personnel proud of almost 17 years of safe operation. Revitusa fulfills several roles. The existing ones are that it is the most important entry point of the national natural gas system. The other two, as you may know, are one in the Bulgarian border and one at the Turkish border. It covers peaks in demand. It plays a regional role in southeastern Europe, especially nowadays when it is already technically possible to send gas to Bulgaria. And it ensures security of supply, about 16 days of average demand. The new roles for which we are working are LNG bunkering, loading of LNG carriers, and truck loading. Let's see now a description of this island. At the center, we have two tanks of 65,000 cubic meters each, and the regasification area, the process area. This is the unloading jetty at which the LNG carriers are berthed. And when the gas, the LNG, is regasified, it follows this way up to the send-out point to go to the continent. We have a cogeneration plant which covers all the electricity needs of the island, control room. And concerning the new installations, the prospective installations, a third tank of 95,000 cubic meters is already under construction. If you see a more recent Google picture, you will see that the works have indeed progressed. In this place, the truck loading station will be built, and this is the area designated for the new jetty area, for the new jetty that will be dedicated to small-scale activities. What has already been completed, excuse me, is the feasibility and cost estimate study for the development of small-scale LNG installations, whose result was the selection of the position for the new jetty, and also the basic design for the construction of a truck loading station. What remains to be done, very shortly, until the end of the year, we will submit the preliminary environmental study for the truck loading installation and the new jetty. We will complete the tender documents for the EPC contract for the truck loading station. And we will issue a tender for the conceptual design at 4 ports of the Poseidon Med II program. Early next year, we will issue the tender for the basic design of the new jetty. And at the end of 2017, although this is outside the small-scale sector, we expect to have the possibility to load large LNG carriers. The ships that now can be only unloaded, we will be able to load them as well. In 2018, the operation of the truck loading station will start. And at the end of 2018, although this also goes beyond the Poseidon Med II program, we expect to have the possibility of loading small LNG carriers with the addition of a new arm on the existing jetty. So, from our side, we expect to be able to supply the first ship with LNG well before 2020. So let's hope that everything will run smoothly and the expectations will become a reality. Thank you.
Thank you, Dr. Florentin, for giving us a very optimistic view of finally having LNG bunkering in Greece. So our next speaker is Mr. Dionissis Christodoulopoulos, Managing Director of MAN Diesel and Turbo Hellas, who is a supporter to alternative fuel technology and its promotion and implementation in existing and new ships. He will give us the MAN point of view.
I hope it's the right one.
Me too.
Okay. Thank you very much for the invitation. As the title of the presentation is mentioned, we will try in a short time to present you which is the main solution for the LNG fueled vessels. So, first of all, as far as I have seen for the previous sessions, you allocate a lot of time talking about environmental regulations, so I will not stay to this, just to highlight that we have already established ECA areas, mainly in the US and the North Sea, and in the forthcoming years, new ECA areas most probably will come in force. And what it is granted is the escalated sulfur content that we have to comply within the next years. So we see also in this graph the development that took place the last many years in terms of the SOx emissions and the NOx emissions. And we see that by 2015 and 16, it will become more stricter. And of course, by 2020, especially for the SOx emission, we will be enforced to have, let's say, to burn very low content with sulfur content of fuel oil. What we have done is, what we were trying to do is to reduce the SOx, the NOx, and the CO2. There are some examples how we are doing via scrubbers or EGRs or high-efficient powertrains, but the answer to most of them is the use of gas. Now, product portfolio, what we can offer you. I took up as an example the Aeropax model, where we can offer from the gas storage and supply system, the gas valve units, the dual fuel engines, 4-stroke at the moment for this type of vessels, up to the propulsion system, up to control and high efficiency propellers. More specifically, we have a huge range of dual fuel 4-stroke engines from around 600 kilowatt up to close to 19,000 kilowatts propulsion, but also electrical generator in the vessels. And because very often we are asked what it happens now and how we can prepare ourselves in the future, almost all of our engines, they can be easily prepared to burn LNG some years after. Here is an example of a dual fuel oil engine prepare that shows some parts like, for example, the gas pipes, the gas valves that have been already installed and can be used afterward quite easily with some minor changes also to burn LNG. We can supply different type of valves and we can also supply C-type tanks with cold boxes and the whole train of the treatment of the storage system. This is the example of a 4-stroke setup, but also we have a presence for the 2-stroke engines. The well-known, the last 2-3 years, MEGI engines, which is actually the version of the existing 2-stroke MEC and engines. We can deliver new engines from 2013 already prepared to burn also LNG, but not only to burn LNG, to burn ethanol, to burn propane and other alternative fuels. This is another example of a vessel, of a container vessel, which actually is a reality nowadays, where we show how we develop this system and how we arrange in the engine room the whole system of course, the main engine, the electrical power, the electrical generators, engines, and of course, the gas valve system, the compressors, and the fuel tanks. So, in one slide, the MEGI and LGI, where they can burn alternative fuels, they don't have the methane slip effect. They can easily operate in heavy weather conditions, and it is already here. We have already thousands of hours in operation for a couple of vessels that they operate mainly in the US coast. However, we are not only for the diesel engines, we are here also to propose rotating elements, and more specifically for the gas transportation and the gas storage, we can propose large number of compressors, gas compressors, but even also for the power generation, gas turbines of various sizes. Here is an example about the range of the outputs that we can supply in the market. Now, something that was specifically asked from the committee of Poseidon Med, what about the emissions? As far as you can see, this graph shows the reduction in the most essential emissions when you use for four-stroke engines gas, minus 20% for CO2, minus 85 for NOx, close to 99 for SOx, and for particulate matters, which is not yet granted in the IMO system as a measurable emission, but it has been established for the power generation. It is also close to 99%. In regards to the methane slip, the four-stroke engines, they have methane slip, and this is not only for MAN, this is, in principle, this is physics. We have two graphs where in the one we present the percentage of CO2 according to the type of the fuel that the engine burns, and the other it is presented in GHG, which shows the CO2, but also in this percentage is accumulated the methane slip. So taking, for example, the G line, the pure gas, you see that in the specific CO2 percentage is close to 65 to 70%, but the greenhouse gases increase these emissions to close 120%. The gap is the methane slip. For the MEGI, it is the problem does not exist actually. And in regards to the reference and the experience, we have exercised several projects. We have executed a new project and retrofits, of course. For four-stroke, for example, we are converting right now under the German state austerity one small container vessel, which is quite young, 2012 built, and we will offer the entire package of equipment that I showed you before. It means from the gas storage up to even the propeller, and to improve also the operational profile of the vessel. Some examples, some references of vessels that they have already four-stroke propulsion system with dual fuel engines, and they burn gas. You see that we can implement this technology to the entire range of vessels, containers, LNG carriers, of course, bulk carriers, offshore vessels, cruiser vessels. And this is, as we call, the most environmentally friendly container vessel. It is built from Tote ship owner, built in US in NASCO. The engine is Korean built, and the first vessel is already in operation close to 1.5 years to 2 years, and the second vessel is close to 1 year and actually is running. We have a decent experience, close to 8,000 hours now, where all the problems, the initial, have been solved, and the vessel is running under very normal conditions. The only problem that is faced the operator is that from the one side of the route, they cannot find LNG yet, and this is what the industry has faced. So we operate the half of the route with HFO, again without any problem. Also another order which is ongoing with ethane fuel oil for Hartmann Reederei, and with the full equipment that we can offer, including CPP propellers, shaft alternator systems, and other peripheral equipment. This is the existing order book that we have with MEGI engines, the two-stroke engines. And this is the reference that we have in regards to the very essential part of one LNG plant, which is the fuel gas system and gas storage. So this is from my end. Thank you very much for your attention. I hope to be in time.
Okay. Thank you, Mr. Christodoulopoulos, for this comprehensive presentation. Now let's move to Professor Christos Douligeris. Professor Douligeris, I skipped someone. Okay. I'm sorry, Professor, I'm sorry. I skipped Glorie. Sorry. Glorie is the Business Development Director of Cryonorm Systems, BV, with 15 years experience in the cryogenic industry, and he is responsible for the small-scale LNG burning with a significant reference list of marine projects, and he will present us the Christos Pallas case.
Yes.
Thank you.
Okay, well, thank you for having me here. I will give a short presentation about our activities in the Poseidon Med II project with Christos Pallas, and I will explain a little bit about the company activities. This is the company in the Netherlands. We're close to Amsterdam. We are active in the cryogenic industry for more than 40 years. We started with cryogenic air gases business, like liquid oxygen, liquid nitrogen, and liquid argon systems. And about 10 years ago, we moved into LNG. For the LNG, we are active in everywhere there is a star. So our company is building small-scale LNG infrastructure, from small-scale liquefaction plants, LNG logistics, LNG bunker terminals, LNG fuel systems on ships, LNG and LCNG filling stations for vehicles, and also LNG storage and regas plants. The retrofit of Christos Pallas to dual fuel LNG, we have done a basic engineering study to see the possibilities of retrofitting the Christos Pallas. The advantage of retrofitting an existing ferry is that we have an accurate, we know the accurate gas consumption, and we know from the experience over the years what the ship is using. So we can calculate the accurate LNG tank size. Well, all the well-known other advantages are there, like low LNG price and environmental advantages. And another thing is that the engine room will stay clean if you sail on natural gas instead of diesel. This graph gives you the fuel consumption, the gas consumption of the Vestas Palace. The challenges we had for retrofitting the Vestas Palace is the heavy and large cylindrical type C tanks, which needs to be installed on the existing structure of the ship. So we needed to have extra construction works on the tanks, which are 5 saddles under each tank. And we have 3 tanks of 150 cubic meters. Another challenge was to find a suitable pipe routing for the LNG bunker lines from the bunker terminals to the tanks or to the tank connection space. The natural gas pipes to the engines, heater watering lines, and the location of the vent lines. The other challenge is we have to find a good spot for the bunker station with the airlock. And our idea was to have a second bunker connection on the car deck for bunkering truck to ship. This is a schematic overview of the system, overall system. This is from the ventilation system, but it also gives the idea about the complete system as we have designed it. You have the gas feed to 2 engines, 2 main engines, 3 tanks, 3 tank connection spaces, 3 airlocks, and 2 bunker stations. Here you can see the position of the LNG tanks under deck. This is a cross-section of the tank connection space with the airlocks. The airlocks are integrated in the tank connection space. The tank connection space, we made it circular instead of square. It's cheaper to build. This is the drawing of the tank with 5 saddles underneath. The future challenges for cost savings on LNG fuel systems is standardization. We need to think about to standardize the tank diameter and length, the position of the tank connection space, design a standard bunker station, and we have to make series. Now we still make prototypes. We receive quite some orders, but every ship is different, and every system we need to reinvent the wheel. So this will not help to bring the cost down. Our references on LNG marine fuel systems. This was our first reference. This was in 2009. It's an inland waterway vessel, tanker vessel with Caterpillar engine. On that ship we have installed a 40 cubic meter LNG fuel gas system. After this ship we have done 2 ships, the Green Stream and Green Rhine, sailing for Shell. Gas electric ships, so it's not a dual fuel propelled ship but gas electric. Each ship has 2 tanks of 40 cubic meters, and in the container there are the gensets of Scania. After these ships we have done a retrofit from the Eiger, which is a container vessel, also inland waterway, and this was our first cooperation with Wärtsilä. So Wärtsilä, they installed the 6L20DF engines with the gas valve units, and we were responsible for the LNG fuel system. After these inland waterway vessels, we have done 2 short sea going ethylene carriers for Antonopoulos. Those ships were built in China, and we have shipped our LNG fuel systems to China and integrated at the Chinese yard. They sail since 2012. The Coral Star, Coral Stigo. This is quite recent project, the Greenland and the Island for Erik Thun. 2 cement carriers sailing in the North Sea and the Baltic Sea. This is the very first ship with a vertical tank on board in the bow of the ship, because the customer, the end user of the ship, he doesn't want to have any LNG tank in his cargo space. So we used the space we got, and that was the bow. We have done a very small tank, 32 cubic meter for Balearia, for the Abo Matut, which was for cold ironing, only for power generation in port. It uses a Rolls-Royce lean burn gas engine, and we were responsible for the fuel system. Our customer was Gas Natural. This was a split hopper barge for Bremen ports with 2 very small tanks, 6.5 cubic meter tank. This one was commissioned last year. This project, we recently signed the contract, which is the Eco Delta. It's a dredging vessel for Van der Kamp. It will have a 325 cubic meter tank on board. And the special thing is that the tank diameter is 7.4 meters. So it's a huge diameter, a very short tank. It's only 11 meters long. Another project under construction is 15 inland waterway tankers. Yeah, I will be fast. Okay. Which are built at VK shipyards in the Netherlands. Those ships will also sail for Shell. And this is also a cooperation between Cryonorm and Wärtsilä. LNG bunkering. We have built an EPC contract for Scangas for an LNG bunker terminal in the Risavika port in Norway, where we have installed about 1 kilometer of vacuum-insulated pipe from the existing terminal to the passenger terminal, where the fjord lines are bunkered. On that project, we have built the flow meter packages, the pump package, the loading arm, the ESD skid. This was a turnkey project for us. So regas, we also do storage and regas terminals. On this project, we have done the vaporizers. Okay, I'll do it fast. This is another project in Madeira, where we have installed the vaporizers, and Chart was responsible for the storage. Another project in Norway, gas-fired vaporizers for Belgium. Liquefaction, this is a liquefaction plant in Ecuador, which we have built. Another liquefier in Rio Grande, together with Sener. Fueling stations, public fueling stations, LNG and LCNG. This is another LNG filling station where you can also bunker small barges from the same filling station. And that's it. Thank you.
Well, that were a lot of projects. So moving fast to the next speaker is Mr. Dionissis Antonopoulos. He's the General Manager of Marine Solutions Sales of Wärtsilä, Greece, with a significant experience in marine engines, and he will give us the Wärtsilä approach after the marine approach.
Good afternoon, ladies and gentlemen. First of all, we would like to thank the Poseidon Med for giving us the opportunity to make this presentation. The title of my presentation is LNG as Marine Fuel Steadily Becoming a Reality. I will go very fast since we are slightly out of time. Wärtsilä has a very extended involvement with products and services across the complete gas value chain, so solutions can be offered from production till distribution. Actually, a year passed since last conference in Zapio, which was held in November 2015, and we have discussed LNG conversions. For this presentation, certain updates concerning Wärtsilä's LNG tank will be presenting, as well as certain latest developments in DF engines. On this slide, the year development of the LNG pack can be seen. 2009, the development started, and by 2016, already 80 tanks are on order delivered. Here we can see certain information and statistics concerning Wärtsilä's tanks. Number of vessels in operation is 18. Also worth to mention that ROPAX and PSV vessels are leading in terms of number of vessels. This slide, here we can see the original LNG tank configuration. Allow me to call it a first version. The tank, the gas valve units in a special compartment and the engines can be observed. On this slide, we can see the upgraded LNG pack with the possibility of having the gas valve units on the engines, or as we will see on next slide, the GVUs integrated in the tank connection space. The heat media skid as well have been integrated in the tank connection in the tank connection space. Such have resulted mainly in maximization of space utilization and fewer interfaces. A further development is the development of a multi-lobe Type C tank, which can offer, in certain cases, better space utilization. Excuse me. Here we can see on the right hand of the slide the multi-lobe tank. Of course, it is expected to have a slightly higher cost than the typical single-lobe tanks. Now, yes, we would like to give an update for the recently announced very efficient four-stroke engine of Wärtsilä, which of course can be selected or retrofitted in the future as a dual fuel able to burn LNG. Concerning this engine, due to the slightly increased pressure required, which is less than 12 bar, a pump will be required in the tank, and the arrangement with the pressure build-up configuration, considering also the pipe losses, will not be possible. So on this slide, we can see the pump required for the W31 DF engine. Here we can see a significant recent reference, which is the ROPAX of Balearia. When entering the service in 2019, will be the first gas-propelled Ro-Ro passenger ferry, which will operate in the Mediterranean Sea and will be among the largest ferries in Europe. It has a length of 232 meters, a capacity of 331 vehicles, and can carry 1,700 passengers. Because of the ship's extensive accommodation facilities and the need to prioritize passenger comfort, stringent standards to reduce and vibration will be applied to Wärtsilä main and auxiliary engine, propeller, and maneuvering thrusters. Last but not least, on this slide, we are showing the latest DF references. We can see thousands of engines and millions of accumulated running hours in different several types of vessels. So I would like to thank you and
thank you for this short but very innovative and very, very interesting presentation. So moving on to Professor Douligeris, Christos Douligeris. He's the professor of informatics in the University of Piraeus with research experience in the areas of communications, networking, security, cybersecurity, and he will be talking us about the project Mitigate. Professor?
Okay, thank you very much for the invitation, for the very nice setup. I would like to change a little bit the theme and present something that has not been heard so far. The fact that now with all the information technology systems, classical systems are interconnected. So we have to look at them together as cyber-physical systems. And when we want to do risk assessment, we have to revise some of the ways we do risk assessment in these systems to include the risk assessment for the information technology part of the systems. With that respect, I'm going to present to you here the work we have been doing in the Mitigate project, which is the multidimensional integrated risk assessment framework and dynamic collaborative risk assessment tools for critical information infrastructures. And in particular, the part that relates to a scenario which we are evaluating among the other scenarios, and this scenario is the LNG supply scenario. the goal of the Mitigate project is, as I said, to look at the risk assessment in a different way, in a way that previous risk management methodologies have not taken into account. That means to take a dynamic approach, an approach which is based on evidence, which means on data that we have and we can evaluate and take good numbers and good likelihoods of events, and then to improve existing methodologies and create a new risk assessment methodology. The project finally will develop this risk management system that will be focused on the critical infrastructure, the critical information infrastructure of the ports. We have been working on critical information infrastructures for ports for the last 5 or 6 years through a series of projects funded by the Greek government and then from the European Union projects. And in this last one, what we want to see is the interdependencies between the global supply chain and the risks that are inherent in all these interdependencies. This slide shows these interdependencies. I think we saw a similar slide before, and I'm sure that all of you here are more experienced with this supply chain of the LNG and other supply chains that we see in the ports. We can see here that where we start from the fields and go to the liquefaction plant, and then we move the products, and then we go and store and then distribute them, and then we use it for power generation or for other groups. And these are complex processes that we have to take and model. And all these processes involve a lot of information technology. And here there's a picture, I don't know how much of this you can see, given the small sizes of the letters, but we can see that there's a lot of information technology involved. So we have to be ready to evaluate the risk associated with this information technology, especially in situations where we have new products, and especially in situations where there is always a fear that these new products have something dangerous in quote marks and so on. So if you put on top of that information technology, we better be careful before we start and design these systems extremely carefully. In the project, we are going to look at some, as we call them, attack scenarios. We'll look at different applications. In the LNG application, we can see, let's say, in attack scenarios here that there is an availability and stop of operations because there's a coordination of bobbings and while loading a tanker. Another tank scenario in our evaluation, we look at hijacking, which is something which we have seen in the last, 5 to 10 years happening many times, especially in the coasts of Africa. And there's an extreme scenario where we compromise the LNG stock while there is an increased demand for LNG due to a very cold front. Another third scenario we are going to evaluate is the delay that occurs in a place during the evaporation process because the critical infrastructure has been damaged either by some event we don't know or by sabotage. And the last one is a classical attack scenario which involves a hacker entering in the information systems of the LNG supply chain and trying to steal some information, which can be accounting or any type of information, or maybe change some of the information, and then we have to evaluate these scenarios. In order to do that, usually we are all aware, people who are working in risk management are aware of the process to work with. What we do additionally is that in the classical strategies like risk estimation, impact analysis, vulnerability analysis, threat analysis, and so on, we add up stages that involve the information technology that we have to take into account and what problems can happen there. And then we have to evaluate the effects and the vulnerabilities and try to find out priorities in what we have to protect and where we have to pay more attention. Another slide that shows the categorization of these threats is here. We have done this for the energy supply. You can see here in different places of the supply chain that I talked to you about, the different places where security problems can occur. People who are from the security area and information technology can relate to most of these issues. What we try to transfer them into the physical world in this scenario of the LNG supply. In general, in the project, as in this scenario as well, we look at interdependencies between the different processes. Because if something happens in one place in the supply chain, it's going to affect the other places. And what we do in the project, I think it's late now to go into the math and so on, but we have a good group of people who are very good in graph theory to try to find out dependencies, estimation of risks in a very efficient way. I will skip the next scenario because it has all the mathematics there, and just finish up saying that we have developed a first version of the system. You can go on the site on mitigate.europrojects.net and try to play around with this, with the tool that we have for risk assessment, and we'll really be very glad if you have comments to improve this, and we'll be glad to share the results of this project and share your thoughts. To thank in this project, I think in the first slide you already saw the names of my colleague at the university who is a big proponent of port information system infrastructure, security and mitigation activities, Professor Polemi, who could not come here because he had another assignment, so I took the role of her here. And also Rafael Company and David Insertis, who are our colleagues from Valencia, but also all the other partners in the project from Germany, Fraunhofer, Eurofar, University of Brighton, the Port of Piraeus and Valencia Port, and several other organizations, a very big group and a project that we are really looking forward to its results, because these results build on our previous work, and hopefully then we're going to have a risk assessment tool that is going to be efficient, effective, and really usable, using all the latest technologies, information technologies. Hope I was on time. Thank you.
Thank you, Professor, for highlighting this aspect of LNG operations. Now moving on to Mr. Joris van Kreij. He is the Global Sales Manager for LNG ship fueling solution of Charge Industries and responsible for the development of the marine business with Charge Maritime LNG Solutions, which he will present.
Thank you, Helen, for the kind introduction. And thanks for the opportunity to speak here to you today about Chart. Let's see if it's coming. Yes. All right. Yeah, I know you guys are ready for cocktails, so I'll try to be as quick as I can. I'll just start with a brief company overview for you, for those of you who don't know Chart yet, and then I'll drill down to the LNG value chain solutions that we have, and then more specifically, of course, the LNG marine solutions, ship fuel systems, and bunkering stations. This is our CEO. If I may quote him, no single company in the world delivers as broad a range of natural gas-related solutions as Chart Industries, from natural gas separation, purification, and liquefaction to the distribution, storage, and dispensing of LNG. So basically, this is just to highlight that we're active in the whole value chain, and I have some more slides on that. We are divided in 3 divisions: energy and chemicals, distribution and storage, and biomedical. No need to go into details here. The distribution and storage division is handling mostly the applications that were discussed here today, and we have operations in Europe, America, and in Asia. Energy and chemicals is our division which manufactures liquefaction plants and brazed aluminum heat exchangers. We'll talk more about distribution and storage. Biomed is a division which is offering solutions for respiratory care products and lab storage systems. Not a topic today. The message is really that Chart is a cryogenic technologies company. Our sales in 2015 was just over 1 billion. We have 5,000 employees in approximate 15 countries. 47% of our revenue comes from the energy market, of which then 30% is LNG related. These are the locations. Here in Europe, our main location is in Děčín in the Czech Republic. This slide shows an overview of the value chain production, as I touched on the liquefaction. And then we go further down, distribution, ISO containers, LNG trailers, all kind of distribution applications, infrastructure, LNG stations for vehicles, satellite plants, as we call them, and the end-user applications, for example, vehicle tanks or ship fuel systems. I will go over these slides. Of course, feel free to go through this and come back to me later if you have any questions on that. Distribution, just as an overview, I already mentioned ISO containers, also rail cars, and the ship bunkering solutions, of course, and I will talk more about that. Storage, bulk engineered tanks, as we call them, vaporizers, vacuum insulated piping. This is all part of the bigger plants that we built, for example, in Norway, where we've done quite a number of projects, but also all over the world, really. The largest vacuum insulated tank ever built was built in the Czech Republic, and we built several of them also in our plant in the US. 1,000 cubic meter, 6 meter in diameter, about 45 meters long. A typical LNG ship fuel solution looks like this. So the tanks, the cold box, piping, bunker stations, controls, and the water glycol circuit, which takes the heat from, for example, cooling water to evaporate the LNG. This is a typical ship fuel tank design. We use a conical support, so that means it allows for the thermal contraction and expansion. It's a very sturdy, very reliable way of supporting the inner vessel. And we have also straps, which allows in that longitudinal movement. Then we have one fixed support and a sliding support, so also the outer tank has that freedom to move. The cold box is integrated, it's airtight, it has all the tank penetrations, the valves, the LNG evaporator equipment, pressure buildup units, instrumentation, and also the controls and those kind of items. It's an ESD protected space, so it's the gas hazardous space, and outside is a normal conventional engine room. Just an example of such a solution. Then some references. In total, we've built now over 10 for over 10 vessels. We built LNG ship fuel solutions. The one on the top is the first project for 3 Fjord 1 vessels back in 2006. The one on the bottom is for Bucebus in Argentina, high-speed catamaran, very special project with high-pressure gas supply, and quite challenging indeed. It was a total solution where we did the whole heat management system, and there were pumps included, so definitely not very straightforward. Then we have the Harvey Gulf, the first 3 Harvey Gulf vessels for which we supplied tanks to Wärtsilä. And then on the bottom, a more recent project right now in production for Rolls-Royce for a fish feeder in Norway. These are 2 barges, basically a power barge where we supplied an ISO container-based solution, so it's more flexible. The ISO containers are changed out full for empty and supplying the gas as a fuel. And on the bottom is a bunker vessel, Monte Arucas in Spain, for which we are supplying the tanks to our partner HAM. Then going to the shore side, bunkering stations. So this is a typical bunkering station. I mean, they come in all shapes and sizes, but this is the basic. The tanks, obviously, pumps, a filling jetty module, controls, and there's also then on the bottom possibility to connect trailers. This is very typically done, so trailers can either fill up or fill the tanks of the plant. The advantage of bullet tanks, so bullet tanks meaning C-type tanks, is that it's very easy to expand, for example, or even go down in number of tanks, you can relocate them. You can take them from their foundation and transport them to another location in case the business asks for a different location. This is one of a dedicated bunkering station in Norway, in Halhjem, 2 500 cubic meter tanks. You can see the filling module. Let me show some more pictures. These are the tanks. There's the pump in between, and there's a foam insulated pipe underneath the road, which goes to the filling jetty module. This is what it looks like from the air. The filling module. So here's where the bunkering takes place. Then we go to a more multifunctional station, Sundalsora. Not only bunkering, it's also evaporation, and it's also a filling place for trailers, so multifunctional. Moshun, the same, also multifunctional station, 5 times 683 cubic meter tanks. Here is another bunker station in Bjuggen in Norway, also with the capacity of evaporation, so it's also the gas supply. And then this is the biggest one that we've built so far, Øra in Norway, just south of Oslo. In total, 6,400 cubic meter of LNG storage, divided over 9 tanks, like this. And this is the last project, which we more recently contracted in, like Klaipeda, 5 times 500 cubic meter LNG tanks. Evaporation, it's also very multifunctional, and it's quite challenging. We're doing it also as a full EPC. So to conclude our highlights, we have 70 years of experience. Actually, this year is our 75th anniversary in our plant in Czech Republic. So there's a lot of history, a lot of knowledge. We have performance-proven high performance of insulation technology. We comply with the highest quality and safety standards. We cooperate with the leading class societies. We try to make it as space efficient as possible. Our vacuum technology is a premium. We have a 5-year warranty on that, and we offer total solutions. So it's a one-stop shop if you come to us. Thank you very much.
So last but not least, Mr. Dr. Paul Davies, the Technical Manager of Risk Assessment, LNG and Alternative Fuels for Lloyd, with 30 years of experience in providing advice on measuring and minimizing safety risks in the marine, chemicals, oil and gas industry, and he will tackle the issue of exclusion zones.
Okay, thank you. Good afternoon. Last. It's not always easy to speak last. After all, what do you actually say at the end of the day, what hasn't been said already today? But what I'm about to present today, this afternoon now, I hope you're going to find of interest. The work was undertaken by Lloyd's Register to set safety zones on behalf of a client. We were looking at the key parameters in setting those zones. It was presented actually last week in detail at the European Maritime Safety Agency, and it was presented to a number of port authorities and flag administrations. The work in a nutshell illustrates the key parameters that are important in actually setting the zone and how they influence the size of the safety zone. It also shows that the zone cannot be simply set by reference to examples in the ISO standard for LNG bunkering. But importantly, it also illustrates the need for more investigation and work to develop a simple way to set the safety zones consistently across ports, to set a zone that is practical operationally, and also to set a zone that affords meaningful protection. So why do we need a safety zone? Well, obviously, first we need to minimize the likelihood of spill, and we need to minimize the likelihood of ignition given a spill. But more importantly, we need to provide meaningful protection of third parties by physical separation. I think it's important to remember that the safety zone does not mean that those outside the safety zone are safe in all circumstances. What it does mean is that third parties will be safe if they're outside the safety zone in most release cases. Therefore, it's important that we still have the need for appropriate land use planning around ports that are bunkering LNG. So meaningful protection. In short, this is a balance between operational practicalities and providing protection of people. So what is meaningful protection? I've listed a few examples here of distances I've seen set in a number of ports throughout Europe and throughout the world that are bunkering LNG. So it could be 10 meters, 25, 40, 60 or more. So what is the actual distance to set? Well, it could be any of these distances, none of them or more, because it's all related to the specifics of the bunkering operation, the specifics of the port itself, and also very important is the local weather conditions. So if I had a ship and a certain bunkering operation, and I took exactly the same ship, same design, with the same means of bunkering to a different port, I may set a different safety zone, but I'd want it to be set consistently. The ISO standard I referred to, they provide in the ISO standard for LNG bunkering 2 examples of setting that zone. The first one is based on the trapped inventory, but this basically is the amount of LNG within the trapped inventory of the bunker hose. And this is released, and they then measure the distance of dispersion of the gas to the lower flammable limit. If we take a typical example of a 4-inch diameter, that's a 100 millimeter diameter hose of about 20 meters, we see that the safety zone would be about 35 meters. If we increase that, because we want to bunker faster, or we had a large amount to bunker, and we increase that to an 8-inch, 200 millimeter diameter hose of still 20 meters long, then that safety zone would be well in excess of 50 meters. The second example given by the ISO standard is looking at a continuous release, where it says there's a release from an instrument connection, ESD doesn't work, and they continue to supply LNG. If we look at this case, then if we supplied at a fairly low pressure of 3 bar gauge, the safety zone would be about 42 meters. If we increase that, doubled it to 6 bar gauge, then the safety zone would be about 55 meters. Now, for a cruise ship operator, Lloyd's Register modeled a number of key parameters to identify those that were important in terms of setting the safety zone, because the parameters are not mentioned in the ISO standard. It's simply related to the trap volume or a continuous release. So you can see here, these are the key parameters we modeled. First, we're looking at the local weather conditions, so atmospheric stability and the wind speeds. We also modeled the release orientation, so whether releases were actually horizontal, as most people would assume, or they're vertically, or they're pointing downwards, or they're horizontal and actually impinging parts of the ship or other bunkering, such as the truck. We also looked at release elevation, so whether the release was at grade, 1 meter height, 3 meters, 5 meters. Again, this is quite important for dispersion of the gas. We looked at release pressure, looking from anything from 3 bar up to about 9 bar gauge. And we looked at whether releases were onto land or onto water, which has an impact on the evolution of gas from the cold LNG. As you can see, as a generality, the results came to us that if we have stable, low wind speed conditions, that's when we're going to get distances that are in excess of the 40, 50 meters. So in stable conditions with low wind speeds, what we'd have in ports probably in Europe, that's when we get the greatest distances if we're bunkering at night time. Release orientation, what we found is that the greatest distances generally is if we have horizontal releases, and the shortest distances, as you might suspect, are if we have vertical releases. That's interesting to know, but it's probably impossible for us to actually think of means to actually preferentially fix the orientation of the release. We also looked at release elevation. That was interesting because depending on the weather conditions and whether released onto land or sea, the results were very different and not consistent. But generally, obviously, vertical releases are important, and they were in this case for a cruise operator, because it sets the elevation, the height of the safety zone, and obviously we may have cabins and other activities going on above the bunker station. Release pressure, as you'd expect, the greater the pressure, the greater the distance. And in most cases, but not all, again, depends on the weather, releases onto water gave larger distances than releases onto land. On the slide there, you can see actually the representative weather we actually modelled in this case. And what's interesting is that the longest distances, as I said, were generally the horizontal distances, and these I'm reporting here, but more than 50% of the cases modelled, and there were many, many cases modelled, exceeded 40 metres. So that would exceed half the time the distances that have been set commonly at some European ports. Interestingly, again, nearly 2/3 of releases exceeded 25 metres, and in some cases the releases were much greater than 100 metres. In summary, the modelling showed the complex interrelation between the key parameters in setting the safety zone. What was key, it showed that there would be danger in actually setting the safety zones based purely on the two examples given in the ISO standard. What could happen is that you could set a zone that is too short, and therefore you don't give meaningful protection, or in fact the zone could be too large, and therefore it would be impractical and be difficult to bunker in the port. So in conclusion, in setting the safety zone, it's actually influenced by many, many parameters, and it's not quite as simple as made out in the ISO standard examples. Because of this, the Society for Gas as Marine Fuel and IACS are now working on a project to see how they can better set the safety zone at ports. So, in essence, further investigation is required to ensure that these zones provide meaningful protection, they're consistently set in ports so that safety isn't used as a commercial advantage, and that they're set consistently between the ports, or as I've said, and the zones are as small as possible, but still providing meaningful protection. We do have a detailed paper on the safety zone, so if you'd like a copy of that, please see me after during the reception. I could organise one. Thank you.
So, do we have time for questions or short? 5 minutes or 5 questions?
No, 5 minutes.
Oh, 5 minutes. Okay.
That we all enjoy the session.
Okay, so I'm just going to ask the marine equipment manufacturers and the engine manufacturers. There has been a lot of discussions the whole day regarding the CapEx and how the CapEx is a drawback for immediate LNG installations. And I would like to have your view on what do you anticipate in the future, what innovations may lie ahead, or what other technological trends may lie ahead that may help to significantly lower the capex of such an investment. So I will start with this way, then the chart first.
Yeah, I think it's really important to cooperate with the regulatory authorities like the class societies and with the IMO to be really clear and standardize the rules that they make, so we can really work basically in a more efficient way, because it's a very immature market. So that means, like Jos also said, it means that you sometimes just inventing the wheel, and that doesn't make it cheap, of course. So I think that's important, and then we need to see what is on the technology side interesting, and for example on the cryogenic field, whether you're working with or without pumps, I think there are developments possible to lower both the capex and opex, for example by taking out the pumps, but really having enough redundancy and enough reliability in order to fulfill the rules and to fulfill the safety requirements. This is basically what we are doing within Chart. We're looking at those kind of innovations to make that more reliable and cheaper, and that just has to continue, because it's just we're basically still on the beginning of this. So, and I think we're in the right direction. Yeah.
Yes, of course, I agree with what Joris has said about the legislation. Of course, we are also putting, as manufacturers, we are putting efforts to improve the current design. So that's why I have shown the original, let's say, tank version, and now slowly we are trying to make a more simple and cost-optimized solution. And already we have seen some indications that prices are becoming more competitive. And last but not least, everything is dependent on the LNG prices. If LNG prices are on low levels, which we believe they will be, then everything is not an issue.
Well, also I think that the classification societies needs to harmonize their standards, because we are building the LNG fuel systems according to the IGF, but still every classification society have their own rule. For example, we made a safety valve calculation, and we were referring to some pages and paragraph on the IGF, and class said, no, this is not enough, because you also need to refer to our rules, which are exactly the same. And on the other hand, in our company, we are standardizing the vaporizers. So we have only 3 types of vaporizers in 3 flow ranges. We are standardizing the skids, so always the same layout, the same for a certain range of ship. And this will also bring the cost down.
Of course, CapEx is related a lot with OpEx. I remember 3-4 years ago when we used to conduct various presentations, the relation between the price of HFO and LNG. And in this time, the payback time was around the 2 to 3 years, with the prices that in this time was more or less 30% more expensive than the current prices. So it is very much related with the situation now that the LNG is close to HFO, or it does not make any sense, let's say, for some people to make by the standalone retrofit of upgrade. And force the manufacturers to reduce the initial cost further, so to make them attractive. And something else that is very important and was mentioned also to some presentation is the emissions, because we are talking about the LNG equipment, but from the other hand, if we stay in the existing technology and the use of HFO, there is a decent OpEx for using this catalysts, the urea, for example, and things, and the elements that they are added on top of the daily operations. So it is very, it is fluctuated at the moment. We don't know how this will be developed in the forthcoming years, and this is related to factors that we cannot control, like the global situation, the pricing of the oils. Okay, thank you.
Now, I would like to ask Dr. Florentin, what are the biggest challenges that you're going to face in this very nice project that you have just described to us?
Well, I think that the challenges are not going to be, strictly speaking, technical. We know how to handle cryogenic liquids. We have a good command of the processes. A problem will be to expand this small group, this small elite of 30 to 40 people, and I'm speaking on behalf of my colleagues because I do not belong to that elite, to several hundreds within several years. Several hundreds who must be trained to the same safety rules and procedures. Regarding DESFA, one important change will be first to fit these new activities within the space of a terminal that was conceived for different purposes, and also that we will need to change our mode of operation. Presently, we receive one ship per month or every 2 weeks. With the development that we see that we will have in this activity, we will need to switch to a 24/7 mode of operation, and this will be a change.
Now, I would like to ask Mr. Paul Davies regarding the presentation on the safety zones. And the question is, what do we have in mind when we are designing a ship to perform LNG bunkering operations? What should we have in mind?
Okay. Could I just say, just addressing one of the comments about the class societies?
Of course.
Sorry. I just wanted to clarify that it needs to be understood that the IGF code is one of the first generation of new codes by IMO that is not entirely prescriptive. It's a goal-based code. Therefore, although there is prescription in there, there is a requirement for risk assessment that may determine slightly different mitigations. Therefore, there may be slightly different interpretations between class societies, and that's what may have happened so far. But IACS have actually issued a risk assessment document of how to undertake risk assessments for all class societies quite recently. In terms of safety distances, I think it's important to make sure that we have something that is simple and that we don't have to keep doing risk assessments each time we're thinking of bunkering a ship. The thing with that is because it's a complex interrelation of the parameters, further investigation is needed in order to set something that provides meaningful protection, but we need to realise that doesn't mean total protection, and we still need land use planning appropriately around bunkering facilities.
Well, the port planners, you should take this into consideration very strictly. Of course.
Because as you extend the exclusion zone, you intervene in the operational part of the port. So
exactly. It would be very nice to do the LNG bunkering operations out in open sea with no one around, but this is not the reality. And actually, this comes to my final question to Professor: how vulnerable is an operation of LNG bunkering in cyber attacks? And do you have any data on that? Do you have any? Good. I'm glad.
We are in the process of modeling and talking to people, and now we're in attack scenarios. So I hope in a few months we're going to have some more data to be able to identify how much vulnerable the energy operations are and compare them, because it will give you a number, compare them to how vulnerable are the other operations in a port, in other means of transportation and so on. At this moment, no. At this moment, we just design the attack scenarios, and we try to go through the process and find the right people to give us the exact procedures, and then to put risk and find vulnerabilities, and then find the final risk factor.
All right, looking forward.
Okay.
Okay, thank you. So we have time for 2 questions from the floor. So, this. Oh, just one. Okay, everybody's looking forward to the cocktail. Can you please identify yourself?
My name is Dionissis. I'm in the information systems and telecommunications market. there is a lot of risk assessment that needs to be done at LNG. I was wondering whether you have set any simulations instead of having, for example, a paper describing the multiple risks involved and the results that you could have. Have you set any simulations in order to test all these things that you have in mind that you described in a paper? And of course, with Dr. Douligeris, there are zero-day attacks that could be done where, for example, we have a time to identify and a time to react to mitigate the risk. So what would you do in a zero-day attack of an LNG? How dangerous is it? And is there any comparison in terms of premiums on gas-operated vessels and LNG ones?
Excuse me, you have too many questions now. Let's hit. So, yes, would you like to answer the first one, please?
Yeah. I don't know anything about premiums, but in terms of risk assessment, there have been a number of risk assessments undertaken for LNG-fueled vessels. Lloyd's Register has actually issued a paper on a risk assessment of LNG-fueled vessels, so I can give you a copy of that. And as I say, in terms of the safety zones around bunkering, that work is still ongoing. I guess what concerns me when I hear of things like 10 or 20 meters, if you're thinking of meaningful protection, in the event of a release, 10 to 20 meters is a very short distance. Yeah. The thing is that obviously the risks are small, but you need to provide some protection in the event it does happen. But obviously these things can be engineered safely.
And with regard to zero-day attacks, our motto is that you have to be prepared and know that port information systems need to be taken into account when evaluating the whole risk assessment procedure and not just stick to whatever traditionally is being done. So if you are well prepared, you are going to react faster. There's no other to do something with zero-day attacks, okay?
So any other questions? No? Okay. Since no one else has another question.
Well, regarding the frequency that the ships are going to be needed to refuel. For example, right now there are very few ships, as Dr. Florentin mentioned, and as time progresses, the frequency of the ships that would need to be bunkered is going to increase. Do you have in mind any operation change that you need to put in place? Do you have some cap on how many ships you can service related to zones, for example, and to any other risk factors?
Well, at the beginning...
The frequency, when the frequency increases of the servicing the ships.
At the beginning, we will have very few ships. Of course, this will build up with time. That's why I mentioned that it will need to be a continuous operation. We will need to have at least 2 bunkering barges that will operate continuously. Of course, if this is not sufficient, then we will need to increase the volume of the barges, which of course brings other problems. It might be more difficult to enter in the port, etc. But we are, I think, at least 10 years far from this point.
Okay, so I don't see any more questions. Of course. Identify yourself, please.
Christos from Rogan Associates. Question to Dr. Davies. The examples and the calculations which you showed for exclusion zones, for safety zones, were for the case of trapped gas in a certain length of hose. Has there been equivalent work with other types of accidents, like puncture of the tank or things like that, in bunkering operations? I mean, not in general in LNG installations, but LNG installation, small-scale LNG installation in a port for bunkering operations.
Okay. In terms of bunkering operations on the ship, collision into the ship, looking at the puncture of the tank, hasn't been calculated as far as I know, who would be a very extremely low likelihood event. In terms of tanks at ports, then lots of work has actually been done on releases of LNG from tanks. And in most cases, storage at port, if it's in a fixed installation, will be covered by the EU Seveso directive. So there'll be detailed safety cases for those installations.
We have to wrap up. So thank you all for staying until the end to this very interesting panel. I think we had a lot of information regarding the technology aspects of LNG, and I think that we're pretty well placed in order to be able to fulfill the demands of the new regulations. And we're very much looking forward to see more installations and more feedback and more innovations on the terms of technology for LNG as fuel for ships. So thank you all, and enjoy your cocktail.
Sorry, just 1 second before. I'll only take up 2 minutes of your time. I'm technically the last person to speak, so if you'll allow me that. Just to wrap up in 2 sentences, the conclusions from today. I was actually hoping to declare the end of the chicken and egg debate, but I think that's going to go on for some time by the looks of things. Obviously, technology exists. Safety procedures are improving. Standardization, we obviously have to move from a prototype to a series, but obviously we need the financing. And listening to the presentations about EU financing before, I'm wondering whether the fast spend that the EU did came at a bad time for the LNG sector, whether we needed more financing at this point. All the same, I think the fact that there's blending mechanisms being discussed will increase the ownership and increase the interaction between the different investors in the sector. But we heard about issues of eligibility, and I think that's an issue that needs to be addressed as to who can actually access that finance. I think the first session was the triumphant, if you like, session of about Poseidon Med. Panos championed the fact that Poseidon Med and LNG can meet the 5 challenges of safety, efficiency, environment, society, and what the future holds. I think we all hope that this is going to be the future. And we heard a lot about cooperation and innovation. And I think the fact that there's so much information and projects being shared in these kind of fora is only going to help push the sector forward. But I'll close with Fernando's point that with cooperation, I think he said we need competition. I think we need to step up and face up to our northern counterparts, if you like, to place the East Med on a more equal footing. So the chicken and egg debate continues. We'll be hoping to see you again at future events of the Poseidon Med project. You'll be kept fully informed by the project team about any events in Greece or in any other country that we're involved with. Thank you very much for being here. Please enjoy the cocktails downstairs. Have a good evening.